Moving on, we're now going to take a look at actually transforming objects, so moving objects, rotating objects using code. So the first thing I'm going to do is to get rid of the old thing. We don't want to develop loads of code for no good reason, so I'm going to right click on it in the project panel and just delete that. And on the cube we've now got this defunct script, so let's click on the cog and remove that component. So we're now back with just a cube and an empty project panel. And as we're going to start building up a bit more code, let's try and organise ourselves nice and early by creating a folder, and let's call that scripts. So we'll have a folder that all our scripts can live in. Jump straight into it. Let's create a new C# script and we'll call this auto move. So we're going to make a script that automatically moves our cube. Double click, fire it up in OnnoDevelop, and we're presented with the same default again. I'm not going to worry about the start stuff. We're not going to do anything at the start. Now we don't need that comment. We know what update does, so let's strip that down a little bit. And we're going to access the cube's transform component to move it every frame. Now transform is a special type of component. It's one that you can assume every game object has a transform, and there aren't many of them that you can assume that about. So if we just quickly flick back to Unity, select this cube, we can see it has a transform. We can guarantee that this directional light also has a transform. However, it doesn't have the mesh renderer or the box collider. And if we flick to the camera, we can guarantee that that one has a transform, but it doesn't have the lighting component. It doesn't have a renderer of its own. It's very different, but the one consistent thing is that they all have transforms. So it's pretty safe to assume we always have that. And that's why we can actually access it by just typing the word transform. Make sure you get transform there, lowercase t. So that accesses the transform component attached to this game object. Okay, so we can do transform dot, and then we're presented with a bunch of stuff. And as ever, if you wanted to know a bit more, you could double click transform, command or control apostrophe, and jump to the help for a bit of guidance. But we're going to work with the translate, so we're going to move this object based on its current rotation and stuff like that. So I'm going to find translate. You can see that it wants a vector 3 or 5 other possibilities. So I'm just going to double click that, open the bracket, and now we're prompted here. So it wants a vector 3 for the translation, or I can cycle through these other options. Notice there we're on 1 of 6. So there's 6 different ways to use this function. Let's press down. Number 2 wants a direction and then relative to what, which can be quite handy. That one again wants a vector and a space. No, we're not interested. This one's getting more into it. So that there wants an x, a y, and a z. And we can work with that. We can give it how much to move in the x-axis, how much to move in the y, how much to move in the z. And let's just take a look at the last two. We've got x, y, z relative to, that'd be good. And x, y, z relative to space again. Let's just flip back to this one. So let's move in the z-axis. So the z-axis is forwards. So let's move our object forwards a little bit. So we're not going to move in the x-axis, so we can put 0 there. And as it wants floats, just to future-proof yourself a little bit, get in the habit of putting f at the end of a number if it's meant to be a float. So 0 would be an integer. It's not a major issue now, it will work with just a 0. But 0f, just make sure that you are working with a float. So like 0.2 would be a floating point number. You need the f. So 0, and then finally we will do a small float. So we'll move 0.1 f. That should be 0 point, not 0 comma. I'm losing my mind a little bit. So that should now automatically move any object with this component forwards 0.1 of a unit every frame. So let's save it up, jump back to Unity and grab hold of auto move, throw it onto the cube, see what happens. And off it goes, walking off into the distance like the end of some cheesy film. But it works. So that's our auto move. You can play around with that a little bit if you like, but there's one way to amend the transform of an object. So that's one component. Let's have a look at another. I'm going to create C# script, and I'm going to call this one auto rotate. Fire that one up. Get rid of start again. Get rid of the comment. And access the transform component of this game object. Transform dot, and then we're looking for a rotate, and we can rotate this object, or we can rotate around another place, another axis, but we're actually just going to use rotate. So I want to rotate in the y-axis. So if I open the brackets, we're now presented with 6 again. We can use a vector 3, which we're not going to worry about just yet. We can rotate vector 3 around an angle. No, there's the one I'm after again. So X, Y, and Z rotation. Now I don't want to rotate in the X, so 0. I do want to rotate in Y, sorry. So what's a suitable amount of degrees per frame? Maybe 10. And finally, don't want to rotate in the Z, so let's put 0 there. Save that. Jump back to Unity, and let's just very quickly make another cube. So we've got a second cube, and let's throw auto rotate onto that cube. So now we've got 2. One that's going to auto move, one that's going to auto rotate. So far so good. Now let's make a third and put both of them on there. These components, the whole point of a component system is that we can make small little behaviours and then stack them up onto a game object. So let's give this auto rotate and auto move. So we've got this one on the left side now, which is moving forward and rotating, which is pretty cool. So we can start stacking up additional behaviour on top. And to keep sort of snowballing it, making it more reusable, these numbers could actually be public properties that we can set in the inspector. So instead of auto rotate just being 10, we could actually have 3 variables here. We can actually do it with 1 variable, but we haven't really covered what we'd need to do that. But we know how to make integers, don't we? So let's make a public integer, public int, and let's call it X rotation. And by default, that's going to be 0. Public int Y rotation. By default, 0. Public int Z rotation. By default, 0. And instead of rotating by hard-coded numbers now, we can use X rotation, comma, Y rotation, comma, Z rotation. Save that, jump back to Unity, select either of the 2 objects that has that rotate script, and we're now prompted with numbers. So this one we could rotate in the y-axis. Let's go 2, it was a bit quick. Same for this one at the end. Let's rotate it 2 in the y and 1 in the x. So it's actually rotating in 2 axes. Give it a go. And he's away. We're getting some kind of funky movement there. Notice that the movement is based on the way they're facing. So the object in the middle going off into the distance is going in a straight line because it's not rotating. This one, it's staying within a reasonable kind of range because it's constantly rotating. And this one's just happily spinning around, being dizzy. Let's do something similar with that auto move. So back into mono, and let's change this to have 3 variables of its own. So the public x speed. Sorry, that should be public float. We're using floating point numbers this time because full integers are a bit too fast. If we're moving 1 unit every frame, bearing in mind 1 cube was 1 unit big, it's moving its full distance about 60 times a second, so it's going to be far away very quickly. So we're going to use a floating point number so that we can go less than 1. X speed, and by default we'll do it as 0f. We'll stick the f on the end. Public float y speed equals 0f. Public float z speed equals 0. And let's replace these. So make use of that auto text, x speed, y speed, z speed. Save it up, click back to Unity, select the cube that makes use of it, and let's give it a z speed of 0.1. Winner. And we might want to make it move up a little bit as well. So let's put, actually we'll move down, so minus 0.05, so a very small downwards movement. And it's going down and forwards. And because the way we amended that class, our other cube has stopped moving now. So let's go to that one. Let's give it some x movement. We'll do 0.1, 0.2 and 0.3 for the z. So that one's got all sorts of rotation and movement going on. It's going all over the place. Let's quickly frame it. Try to follow it. It's a bit hard. Where's it gone? Where's it gone? There he is. Flying away to the sun. Okay, so we'll stop there. And just try and get back to where we were. There we go. So hopefully you can see the way you can start to combine components to make far more interesting behaviour. We can take it a little bit further. Let's do one more that's a bit more mathematical. We'll have a bobbing function. So we'll do auto bob. Create a C# script that auto bobs. Fire that one up, and I am going to use the start this time. This isn't going to be perfect, but you'll see it in action. So I'm going to make a variable that remembers where this object started. So I'm going to have this private. We don't need to see this outside. So this is going to be a private float start y. So we're going to remember where it started. And to do that, we'll access it in this start function. So in the start function, I want start y to be transform dot position dot y. And then down here, what would be very nice in C#, one of my only gripes with it is that we can't do something as simple as transform dot position dot y equals and set it to something else. If I do try that, if I say I want it to be at 5 and just quickly throw auto bob onto this and then hit play, notice we get an error. It's saying we can't modify that particular property. We can't modify the y property of our position. We've got to store it in a temporary variable. So we'll do that. We'll make a temporary variable just above. Let's make a vector3 because that's what it is. I was avoiding using a vector3, but it's prompted me to. Let's call it pos. So I'm just getting the position. Vector3 position equals transform dot position. And we want to amend this y position. So now that we've stored where it was, we can actually amend it here. So instead of being transform.position.y, we can use pos.y. So pos.y is going to use a sine wave to go up and down. I'm just going to do that by taking mathf dot sine or sin, and then in there we need some number that is ever increasing, and luckily enough Unity tracks time for us, so we can do time dot time. Time dot time, but we're not quite done there. We want to base it on where it started, so we're going to do plus start y. So we're going to add its starting position to this sine wave, and hopefully when we finally come back and apply that as our new position, so if we do transform dot position equals pos, so we've stored the position at the start, We've then amended it with a sine wave, and now we're going to set it back. So our temporary variable is being fed back into the transform's position. There's quite a lot going on in those 3 lines if you've never coded before, but let's see it in action and it might help to process it. So we've got AutoBob on this one. Let's run it. Now we can see now that it's bobbing up and down in quite a smooth manner. And just let's dock the game view so we can see it bobbing up and down, but we can also select it in the scene view here and see what's going on. So if you watch its Y position there, it's fluctuating between 1 and -1, because if you know anything about a sine wave, or any sine or a cos wave, they will go from 1 down to -1 and back up in a nice, smooth, flowing movement. And I think for now, again, to keep the video small, we'll leave that one there. So we've made 3 new bits of script, and we've combined them in interesting ways, and hopefully you're developing your understanding of the way components can be used to build more involved behaviours. See you in the next vid.